Welcome, ladies and gents, to your week one of term two. General maths this term. Obviously, everything is going to be from home. We'll got a few things to try and help you out, so a little bit better than the final week of last term. So the plan is every week we're going to send you out what are your tasks and essentially your requirements for the week to come. You're going to have textbook exercises as you normally would do. I've got a Zoom scheduled in each week during our Wednesday lesson. So that's to try and help you out. And the details will be in the email that I send you out as to how to get into that and the exact time. Everything that you need is contained within the OneNote. So what we're going to do is we're going to switch across, have a bit of a look at the OneNote, make sure you know where you're going. Once again, the OneNote link will be in the email if you haven't accessed it, just to make sure that you know what you're doing. So we'll just bring up OneNote now. So with our OneNote, what we need to make sure is we're still in the Unit 1 section, and we need to scroll all the way down to where we get to week one, term two. So this page here actually has all of the documents that are going to be required for the email. So you've got your term two planner, the Cambridge Go information, I'll talk about that in a second, your term two proficiency scales, the PowerPoint just for this week, even though it is embedded in the individual lessons, a sample of your Cornell notes. So if you don't have your Cornell notes, you can print that out so that you can make sure that you're writing thorough notes for each lesson. You have a diagnostic exam on this Thursday. Was scheduled for this Thursday, but I need to have that by 3:30. For that diagnostic exam, there's also the formula sheet that you are allowed to have and use. So looking through your lessons for this week, you've got percentages, markup, and discounts. Once again, all of your details are in here. I've included the worked examples from the Cambridge website. This week, you do need to make sure that you are logging in and checking you can access Cambridge. From next week, you'll start to have weekly quizzes that need to be conducted within Cambridge, and that will be your regular feedback. Within the profit and loss, once again, very much the same, all your learning intentions, and then you've also got your solutions for your PowerPoints as well and work solutions throughout here. Diagnostic test is loaded in. Once again, you need to make sure you are actually doing your diagnostic test. It needs to be emailed, so scan, photographed, I don't care how, send something through to me by 3:30 on Friday. So what we're going to do is we're going to have a look at the worked examples that we would normally do it through our lessons in each week. So it is a little bit faster, but you can pause, rewind the video, obviously, as you need to get through. There we go. So this week, in terms of general mathematics, sorry, just grabbing my screen up so I can work through this with you. So we've got two lessons of work, as I said. We're doing your diagnostic in by 3:30 on Friday, and you must check that you can access Cambridge Go. So percentages, applications, including markups, discount, profit and loss, GST is where we're on today. So we want to make sure that you know about percentage markups and markdowns, and markdown essentially is a discount. I'm going to work out how to calculate those percentages, markups and percentage discounts, and express an absolute markup or discount as a percentage. So in terms of a markup or a discount, whenever we're describing these discounts, it's always in relation to the original price. That's our go-to when we are doing this. So it's around what is the actual initial price. So if it's a markup, it's your purchase price, and if it's a discount, it's the original marked price. So for example, if we had something like, just grab my pen, oops. If we had something that, for example, was $100, if you had a 10% markup, so you're purchasing it for $100 and you're going to sell it for 10% more, we're going to add 10% too. So it's $100 plus your markup. Sorry, my writing's a bit messy on here. So the markup is going to be our percentage multiplied by our original. So we have 10%, and the easiest way is always to think about a percentage as a decimal. So 10% is 10 out of 100. So 10 out of 100 which equals 0.1. So the actual markup itself, if we have a 10% markup on the $100, is 0.1 times 100, which is, of course, $10. So we're going to have $100 plus our $10, which is then going to give us $110. Bear in mind, I'm going to go back to doing whiteboard for this because I'm not as good with using the pen in this context. So my apologies. So our other way of looking at a markup or a discount, which works out exactly the same, is that we're actually, with a markup, we're being charged 100% plus 10%. So when we add that together, we're actually being charged 110% of the original price. So if it's $100 plus 10%, it is 110% of 100. So 1.1 times the 100 gives us $110. So if we were to redo this and think about this as a discount, just going to get rid of all of this. If something was let's just stick with our $100. If the sale price of something, if our sale price is $100 and our discount is 20%, we're being charged, so our sale price, our discounted price is 100% minus 20%, which is 80% of our original price. So therefore, we would then say, well, our total discounted price is 0.8 because 80% is 0.8 multiplied by our original price, which is 100. So therefore, it is $80. So in summary, if we have a discount, the discount is off the final price. So a discount, a 20% off is the final price, is 100% minus the 20%, so 80%, so 0.8 by the original price. And a markup is the final price based on the initial sale price, the purchase price. So we're adding 10%, so it's 110%, which is 1.1 times the original price. So trying to do an example. So a refrigerator has a selling price of $682. A customer bought the refrigerator on sale for $511.50. Determine the percentage discount that the customer received. So what we can look is, well, what's the ratio of that final price over the initial price? So it was $511.50 over the 682 is essentially our ratio. So that is going to give us 511.5. I'm just using my calculator, divided by 682. So we end up with 0.75 or 75%. So the amount that was paid in the end was 75%. So backtracking, so 100 minus the discount percentage equals 75%. So 100 minus 25% is 75%. So we can work out on this one reasonably quickly that the discount was a 25% discount because the end ratio was 75%. So after a 17% discount, the shirt is advertised for $49.80. Calculate the selling price before the discount. So our ratio is going to be 100 minus the 17%. So that's 83%. So we know that 0.83 multiplied by the original price is $49.80. So using a bit of rearranging, we can say, well, the original price equals the $49.80 over 0.83. So once again, using my calculator, so 49.8 divided by 0.83 is $60. So therefore, the original price was $60. A shoe shop marks up an item by 145%. If a pair of shoes sells for $47.78, what was the original price? So our ratio, our sale ratio is going to be the 100 plus 145%, which is going to give us 245%. So using our same process, our final price is 47. So 47.78 is 2.45, so 245% as a percentage, multiplied by, I'm just going to use X for our original price. So our original price is 47.78 divided by 2.45. So using my calculator again, 47.78 divided by 2.45 gives me approximately $19.50. So the thing we've got to be careful of is if we have multiple discounts or markups in a row, you can't add and subtract these together. You have to do each one separately. So an employee receives a 12.5% discount on a store purchase, even if an item is already reduced. The employee wants to buy a pair of $275 Ray-Bans. Its order being reduced by 40%. What will they pay? So let's separate these out. So we've got, put my pen in all sorts of places. So the important things are our original price is $275. We've got a discount here of 40%, and then we've got a second discount of 12.5%. So we're going to have our 275 multiplied by discount 1. So if it's 40%, our ratio is going to be 100 minus 40, which is 60%. We're then going to take whatever price we've received from here, and we're going to apply another discount to it. So we're going to have 100 minus 12.5%, which is 87.5%, or 0.875. We can use a calculator. So now 275 multiplied by the 0.6 to apply our 40%, and then we're multiplying it by 0.875 to apply the second discount, is going to get us to an end price of $114.38. So for our second lesson, we're also adding in GST here. The main thing with GST is it is 10%. It's that fixed 10%, and so a pre-GST price excludes that 10% added on. The 10% is just the same as markups as of the original price without the GST. The second part is with profit and loss. So similar to discounts, a profit percentage is based off the cost price. So profit percentage is the original price added on. So the GST is working in exactly the same methods. Got the wrong way. Okay, so if Talia buys jumpers for $28 and sells them in store for $42, what's the profit made on each jumper? So the absolute profit is the 40, so the absolute profit is the sale minus the cost. So 42 minus 28, so $14. The profit percentage, so the percentage is always divided by the initial, so that is the profit divided by the cost, so 14 over 28, so 0.5, which is then 50%. Jan Jeans buys a shipment of 50 t-shirts at a cost of $17.50 per shirt. After selling just 10 of them at $25 each, Jan sells the remainder for a loss of 8% on each shirt. What is profit or loss made? So what we need to work out is what was the cost. So overall, so the cost was 50 shirts multiplied by 1750. So 50 by 17.5, so is $875. What was our sales? Well, we've got 10 shirts by 25, which is $250, and then the remainder for a loss of 8%. So there's 40 multiplied by, so sidebar over here. So we've got, if we've got an 8% loss, that's the same as looking at an 8% discount. So we've got 100 minus 8%, so 92% of the cost price is what they're sold for. So we want to say, well, 0.92 multiplied by the 1750, $16.10. So we sold these for $16.10. So we're going to multiply by the 40, so $644. So the total sales is going to be, adding these two together, so $894. So our profit equals the sales minus the cost. So the 894, sorry, the total sales was 874 minus 800, sure, I'm going crazy here. So 894 was our sales minus our cost of 875 is going to give us $19. So therefore we have a $19 profit. So we want to calculate GST. So remember, as I said, GST is 10% based off the initial cost price. So if the cost is $35 pre-GST, then GST equals 0.1, which is 10%, multiplied by the $35, which is $350. GST added to a car advertised. So we're working at the GST added to a car if it's advertises 10,670 GST inclusive. So we've got 100% and we're adding 10%. So the GST inclusive price represents 110% or 1.1 times the original cost. So what we can do is we can say, well, the original times 1.1 equals 10,670. So the original equals 10,670 divided by 1.1. So our original price was 10,670 divided by 1.1, which is 9,700. So our GST is the difference between the two, or we could just multiply that. So GST equals our 10% of the 9,700, which is 970. And we can certainly check 970 plus 9,700 is 10,670. So that has worked out. So that the price, including GST of a haircut, costs. So we need the price including GST if a haircut costs $28, not including GST. So using our same ratio, it's just going to be our $28 multiplied by 1.1. So $30.80. Because we've already worked out the ratio is 1.1 with GST. And the pre-GST price of a theatre ticket that cost $120. So once again, same thing, 120 divided by our 1.1. So $109.09. Yeah, I'm not writing too well today. Okay, so Best Buys. So the idea with Best Buys is usually where we look at getting to a unit price. So in our example here, stores often sell the same product in various sizes. For example, Coles selling Wheat Bix, you got a 375 gram packet for $2.90, 575 for $3.80, 800 gram for $400, 1.2 for $500. So when we're trying to work out which is the best buy, we want to work out per unit. So we can work out per gram, we can work out per kilogram, whichever is more effective. Now, obviously these days at supermarkets, there's a legal requirement that they display this, but it is good being able to work this out for yourself. So in terms of calculating this, we just take the price divided by the quantity that's there in the units that we're comparing. So if we're doing it per gram, we're dividing by 375, 575, 800. If we want to do in kilos, we just do it as 0.375. So we've got 77 cents per gram for the first, 66 for the second, 50 cents for the third, and 0.5 cents and 0.42 cents for the final. So, I mean, our best buy is the 1.2 because the cost per gram is lower. So generally speaking, buying in bulk is going to be better. That is not necessarily always the case because in the real world, sometimes a smaller pack is actually more popular to buy, which means there's quantities of scale, which means that price becomes smaller. So it doesn't necessarily work out the way that you would want. Also, if we're comparing different brands, then there will be differences between the brands as well. So we have to be careful of the context. Buying more isn't necessarily buying cheaper. So looking at an example here, we have got the same brand of coffees available in 3 sizes based on the cost line, which represents the best buy. So if we've got, so for this one here, let's work out the price per gram. So for our first one, we're going to have $4.60. We're going to divide it by 50. So we have 0.092 per, and our unit is gram. For our second one, we've got $9.40 divided by 125 grams. So $9.40 divided by 125 is 0.0752 per gram. And then we've got $15.40 divided by 225 grams. So 0.068 per gram. So our cheapest is the $15.40 at 6.8 cents per gram. Now, realistically, we should actually make the mathematical statement and go, you know, 0.068 is less than 0.0752, which is less than 0.092. Therefore, the 225 gram pack is the cheapest unit price. And our last example, Julie lives by herself and uses milk in her tea. She can purchase 3 litres of milk for $4.89 or 600 ml for $1.10. Decide which milk she should buy and why. So once again, we're going to do our unit price. So we have $4.89 divided by 3 litres. So we have $1.63 per litre, and then we've got $1.10 divided by 600 ml. So once again, we need to make sure we're using the same units. So I'm going to say 600 ml is 0.6 litres. We must use the same units. So we have, wow, that is not great writing I've done over here, sorry. $1.10. So $1.10 divided by 0.6 is 1.83 per litre. So 1.63 is less than 1.83. Therefore, the 3 litre is the cheapest. And I guess we have to then make a statement where this is assuming she drinks it before expiry. If she ends up wasting an amount of it, it may not be the cheapest. So your task is exercise 2A. You need to do questions 3 to 18 and exercise 1E, questions 1 to 7. Any problems at all, shoot me through an email. I will see you all in your Zoom meeting this week on Wednesday. So looking forward to that with everyone. Have a fantastic week and bye from me.